Hi, my name is Clay from OpenC3, and in today's video, I'm going to show you how we can leverage large language models to configure Cosmos telemetry screens very quickly and easily. Let's get started. So if you're familiar with Cosmos, you should know just exactly how powerful Telemetry Viewer is. From Telemetry Viewer, this is how we'll primarily make our screens or different type of widgets and UIs so that we can visualize all our different telemetry entry points coming in and building out custom functionality around it. So in this example, this is our demo plugin. So we have the health and status screen that we have here where we can look at all the different telemetry points coming in, including showing the limits bar so we can understand exactly how our target is performing. We can also visualize other things, including, let's see, some latest information. So these are just the latest data that's coming in from our simulator here. We have limits, so we have a way to visualize a variety of limits that are happening. If you have limits defined for your target, you can specify exactly what those limits are and then monitor how those limits are performing. And it's just showing all the different ways you can display that. We have also rollups, so you can generate rollup statuses. You can build out your subcomponents, have individual limits, and then from here I can then open up individual rollup statuses as they're available. So we have some limits, we have some health and status information, and then we can also show some generic images to show what the telemetry connections look like. These custom screens that we built for Cosmos uses just a text definition. So if you open up those edit files, you'll see that they're just text files to edit. And then in our documentation for screens, you have all the different information about all the different settings that we can set in order to get these screens to show exactly what you want to show. And there are a ton of options. There is so much you can do with this and so many different custom screens you can make. And at the very bottom here, this might be an example file that you may have showing all the different ways you can show your telemetry information, your different commands, how you want to set up your UI so that you can get exactly all the information you need all in one place. Now, this is fantastic and it's a pretty easy thing to configure, but let's say we're still lazy and we still don't want to do this. We can make whatever we want this simply, but we still don't want to do it. Well, that's great because this is a great use case for using our large language models that we have access to. So in today's example, I'm going to be using Claude Code as the CLI option. I find this to be very, very useful in some of the new models with Opus. It's really tremendous performance. So what I'm going to ask it to do is please look at the telemetry screen documentation to build telemetry screens. Then take a look at, and this is the directory that contains all the different examples that the demo comes with. Then understand the command telemetry database in my Arduino Sensor Kit. So in this example, I'm going to be using the Arduino Sensor Kit, which I've shown before. So take a look. We'll post a link to the GitHub repo. It's all open source and public, so you're welcome to take a look at that. Then create individual screens as separate files in my Arduino Sensor Kit directory for screens. So we're just going to hit enter and we'll let it do its thing. So I'm going to fast forward here and then we'll come back once it's ready. All right, so it came up with some ideas. So I'm going to let it create this status.txt. Yep, great. Then it's going to keep thinking, maybe make some new ones for me. All right, it's ready to make a BMP 280 environmental sensor. Great. Let's get that made. All right, it has now proposed an accelerometer.txt. That looks great. It's also proposing a DHT20, which is the temperature and humidity sensor. And next one, we have the sound sensor. So let's go ahead and make that. And it's also creating a commanding.txt file, so we can do some commanding from a screen. All right, so it looks like it's finished up. I'm cooking up something exciting for us for all these different screens. So I'm gonna go ahead and go into our Arduino Sensor Kit here, and I'm going to want to build the gem so we can actually load this in. So I'm going to make a new version called 1.0.1, hit enter on that, and that will generate our Ruby gem. Now that our gem is created, we're going to want to install this new gem onto Cosmos and install our Arduino Sensor Kit 1.0.1 gem. So we're going to hit OK, install that, and I have my sensor kit connected and the bridge working right now. So once it's installed, it should start communicating directly with it. Yep, and on our command to learn server, it looks like the connection is successful and we are receiving telemetry. Awesome. So now, if this is the first time I'm looking at this, let's take a look at what these screens look like. So the new ones that I created, so we have accelerometer. Nice. So we have graphing of different accelerometers. So if I move this around, it'll instantly start reacting and those spark lines are going to have new numbers. That looks great. I'm going to look at BMP 280. Okay, cool. So this is the environmental sensor. The BMP 280 is tracking temperature, pressure, altitude, and some graphs. So that looks pretty nice. We have some limits information here and just some metadata about the packet, when the last packet was received, some receive count information. Let's take a look at DHT20, which is the temperature and humidity sensor. Again, we have temperature data, humidity data as graphs. And then I think it was working on sound. So as I'm talking into this thing, that value will spike, just kind of showing that the decibel meters are changing. And we can get some graphs of the history there. And then there's one about control, commanding. There we go. So cool. So it looks like the colors are a little strange, but we have the LED control. So if I click on, that LED turns on. If I click off, LED turns off. Buzzer on, kind of hear that through the camera. And buzzer off. So that was just a very quick demo of how we can very quickly generate screens using just leveraging all this technology from large language models. There's no need to like reinvent the wheel. And of course, some of these are going to be rough drafts, but it should be the catalyst that takes you to 80% of the solution. So that from there, then you can do some tweaking and that's where the magic happens. So really trying to leverage all these existing technologies to take you to the 80% as quick as possible. All these prototypes are done. And then the fine tuning, that'll be where your expertise comes in. So thank you again for watching. If you have any comments or ideas or anything that you'd like to let us know about, reach out to us on LinkedIn or GitHub. We're always more than happy to chat. So thanks again for watching and catch you next time.